All right, baby. Welcome back. Welcome back. Get fucking hyped. Get fucking hyped. Welcome back to another zero to deployment video where we build awesome stuff, just really cool shit from scratch. And in this one, we're going to be building our own dog breed identifier app. So all of you dog people, you're going to love this. And the app is available on Play Store. You can go download it right now. It's called DogNet, and check it out. Let me know what you think. So let me show you how the app looks like. So first of all, this is the sort of the homepage. You can take a photo from the camera, and then there's also a gallery. So for example, let me press the gallery, and then we can, I don't know, pick this photo right here. By the way, all of these photos I've just downloaded. They aren't from the data set. So then let me just pick that one. Then the model is running, and it'll give the predictions for that one. So in this case, it's a golden retriever, pretty high accuracy. And then there are some other cool stuff, like you can help the model improve by labeling that example and then uploading it. So you can press, was this right? And then you can say, nah, it was a beagle. And then you can press upload for that one. And then there's also a dog page where you can read more about sort of all of the different dog breeds. So let's say you would be interested in reading more about this dog, then you would press that, and the Wikipedia page would open for that dog, and then you can, read about it. All right, that's what we're going to do. So, or actually, disclaimer, we're not going to be building that entire app just because it's going to make too long of a video. So the outline for the video is that in the first part, we're going to be building the model or training the model. And we're actually going to use a pretty unorthodox approach with using PyTorch and TensorFlow. And then we'll convert that to a TF-Lite model, and we'll build the app which uses that TF-Lite model. With that said, let's get started. All right, so let's create a new project, and we'll call that DogNet. Or actually, we need to do one thing first. We need to actually have data. All right, so for the data, there's going to be a link in the description, probably to Kaggle, where you can download the data set that I'm using here. And so it's basically just that we have a data set where we have 50 examples per dog breed class. And then we have a dev set where we also have 10 examples per class. So that's what we're working with. Let me create sort of the files that we're going to use. So we're going to have a train function, or train file. Then we're going to have a dataset file. And then later on, we're going to create a convert to TF-Lite. All right, so starting with the train function, let me just do all of the imports. So we're going to be using NumPy. We're going to be using OS, and then we'll set os.environment, and then tf cpp min log level. And for those of you who watched all my previous TensorFlow tutorials, know that this is just so that we can ignore the warnings from importing TensorFlow. So then we'll do import TensorFlow as tf. From TensorFlow, we're going to import keras. From TensorFlow.keras, we're going to import layers. We're going to be using TensorFlow hub, so import TensorFlow hub as hub. And that's essentially where we'll have a pre-trained efficient model that we will be using. Then from dataset, import get loaders. So we haven't created this one yet, but we'll create that pretty soon. And then we'll do from tqdm, we'll import tqdm. And that is just so that we get a progress bar for the current epoch. All right, so let's start off with setting the physical devices, which is tfconfig.list physical devices, and then GPU. And then we'll do if length of physical devices is greater than 0. We'll do tfconfig.experimental set memory growth of that GPU. And this has helped me a lot to not get CUDA errors. It might not be necessary, but it's a safe sort of precaution to take. All right, so let me copy in a URL right here. And this is going to be the URL to TensorFlow Hub, where we download the feature vector associated to an efficient net model. So we're going to be using the smallest efficient net model just to make it a little bit faster to train. And that is the efficient net B0 model, which requires or takes as input 224 by 224 images. So what we can do is we can set all of those hyperparameters. Image size is 224. The batch size we'll set to 32. And here the image size is dependent on the model. So if we increase this to B1, for example, then you'll need to change the image size to, I think, 240. So just remember that if you're changing the efficient net model, also change the image size. All right. So then we'll do the number of classes. In our case, we have 127 different dog breeds. We'll set the number of epochs that we want to train, and we're just going to set that to 3. The data directory is just in data. And then we'll do a model path, sort of where we want to save the model later on. And we'll do efficient net B0. Auto-tune is tf.data. Actually, we don't need that, I think, so we can remove that. Then we'll do load model equals false in the beginning. Also, one thing you gotta set when you're loading the model from TensorFlow Hub is os.environment and then tf-hub download progress. We'll set that to 1, and then we'll do os.environment tf-hub cache directory. And this is just so that it'll actually save the model that we are loading. Otherwise, it takes forever also. So we'll just set that to some location on the computer. And then we're done with the sort of the initial setup, I guess. And so let me create the skeleton code first of all. We're going to create a function that's going to be get model. Then we're going to do a function that's train step. And so essentially this is going to do one train step of our network. And then we'll do one evaluate model and also one main function. So then, we'll check at the end if name equals main. If that is the case, then we'll run the main function. So I guess now is a good time to start doing the get loaders also, so that we know how to load the data. And this is actually one thing that's unorthodox in the way I did this. I like PyTorch more and I'm more comfortable in PyTorch. So what I did is that I actually created the data pipeline using PyTorch and then sort of just running the model in TensorFlow. There are probably better ways to do it, but that's how I did it. So I'll just show you how to do it that way. So for the data set, we're going to do some imports, OS. We're going to import TQDM. We're going to import torchvision.datasets as datasets from torch.utils.data. We're going to be importing weighted random sampler and data loader. And the reason why I'm showing you, so this is one thing that I showed you in my last video, where I have a tutorial on how to deal with imbalanced classes using weighted random sampler. And the reason why I'm showing you in this way is because then your data input pipeline will be more general, in the way that if you would have more dog breed more examples for a specific dog breed, then that would be handled by our data pipeline. Now, in our case, we have 50 examples per class exactly, so the data set is perfectly even. So this would be an unnecessary thing to do in our case. But just to make things more general, I'll show you how to do it that way. So then we'll do import torchvision.transforms as transforms. All right, so define get loader. It's going to take a training directory and a dev directory. dev directory. So the directory to the training set and the directory to the development or validation data. We'll also send in a batch size and then an image size. All right, so then we can just do something print like getting loaders. And then we'll do train transforms. And this is just going to be pretty standard. All we're going to do is first resize the image to 300. And then we'll do a random crop. And then we'll adapt that to our image size. So image size. And then we'll do a random horizontal flip. So we're not doing any fancy or heavy data augmentation. We're just using sort of the basics. We're using a horizontal flip, and then why not, we could also use a vertical flip, maybe not with the same frequency. So let's set a probability of 5%, and then we'll just convert that to a tensor. So for the dev transforms, we'll do the same thing. Transforms compose of transforms resize to image size, and then transforms to tensor. All right, so to load the data, right, this is our folder setup. We have some folder data, and then in that we have the train and the dev, and all of those are perfectly distributed sort of in subfolders. And what we can use then is the image folder. That's a very easy way of loading the data. So let's create a train data set, which is going to be datasets.image folder. We'll send in a root directory, and the root is just going to be the train directory. Transform equals train transforms. And then we'll do the same thing for the dev data set. So the only thing we're going to change is just the root directory. That's the dev directory. All right, so now that we have those, let's now do we can do the validation loader, because that's just going to be a data loader of val dataset or dev dataset. And then we'll set the batch size to batch size. We'll also set the number of workers. Let's set it to 2, and then pin memory equals true as well. You could do exact same thing here for the train loader, but that wouldn't be a very general sort of way of loading the data. So I'll do the weighted random sampler for dealing with imbalanced classes. And if you want to see more about that, you can check out that video. But basically, we're going to create some class weights by going through and checking exactly how many files do we have of each dog breed. So we'll go through the train directory. We'll check if the length of the files is greater than 0. Then we'll add that. So we'll do append 1 divided by the length of those files, adding a weight to that specific class. So if there are more examples of that particular class, the weight is going to be lower because we're going to be dividing by a larger number. All right, for the sample weights, we're gonna do just initialize it as 0, and then we'll just do that for the length of the training data set. So then we'll need to go through all of the examples in our training data set. So we'll do for index and then data comma label in enumerate of TQDM of train data set. And you can do it this way. It'll do a little bit more computation this way. So one thing you can do to speed it up is just do .images, because if you think about it, you don't actually need to be doing all of the resizing and so on when we're computing the sample weights, because all we're interested in is what is the label of that example. So we'll do class weight is the class weights of that particular label. Then we'll do the sample weights of that index, and we'll set that to the class weight. And again, sorry if I'm doing this quickly. It's just because I have a separate tutorial on it, so you can check that if you want more details. All right, so the weighted random sampler will send in the sample weights. We'll send in the num samples. It's just going to be the length of the sample weights. And then we'll do replacement equals true. All right, so now that we've done that, we'll do the train loader. So that's going to be data loader of the train data set. We'll set the batch size to batch size. We'll set the sampler to sampler, and then we'll specify the number of workers and pin memory equals true for a little bit more efficient data loading. So then we'll just return the training loader and the val loader. All right, so now we've returned those. That's sort of our get loaders. So in our main function, we can now run that. So we'll get the train loader and the dev loader, and that's going to be the get loaders. All right, so for the get loaders, we need to send in the train directory first. So that's going to be the data directory plus train, and then for the dev directory, it's data directory plus dev. Then we also need to send in the batch size and also the image size. Okay. So then what we'll do is, I guess it's better to implement those three functions right there first. So the get model is just going to take as input some URL, the image size, and then the number of classes. So what we'll do is we'll do model is tf.keras.sequential. And here we're just taking that pre-trained feature vector or that efficient net model using hub keras layer. And then from that URL, we'll specify that it's trainable as trainable equals true. Then we'll do some additional sort of fully connected layers after that. So we'll do 1,000 nodes. We'll specify the activation to be relu. And then we'll do dropout in between. So maybe 0.3 dropout. And then layers.dense to the particular number of classes. And we'll also do softmax at the end. So activation softmax. And I guess what's important to do here as well is to build a model. So we'll do model.build. We'll specify an input as none for the first, which is the batch. And then we'll do image size, and then it's going to have 3 channels. And that's it. So we'll just return the model after that. Now for the train step, we're going to wrap this in a TF function for some additional optimization. And we're going to be sending in some data, some labels, some accuracy metric. We're also going to be sending in our model, our loss function, and then the optimizer. All right. So we'll do that in a TF gradient tape as tape so that we can measure the, yeah, I'm assuming you know TensorFlow. So, and if not, I have 20 tutorials on TensorFlow. This is a little bit more of an advanced video, I'd say. All right, so then we'll do predictions is model of data, and then we'll specify that training equals true. We'll create the loss using the loss function, where we'll send in just labels and predictions. All right, so after that, all we'll do is we'll get the gradients by doing tape.gradient loss and then model trainable weight. And we'll apply those gradients to the optimizer. So optimizer apply gradients, zip of gradients, and then model trainable weights. And lastly, we'll update the accuracy metric, which will be sort of a running accuracy across the epoch. And then we'll do update state of labels and predictions. All right, so actually I noticed that I missed one thing here, in that we want to, since we're loading the data in PyTorch, we need to swap the axis for the number of channels, because the channels is, they're not structured in the same way. I think specifically we have like this for PyTorch, where we have the channels and then we have height and width. But in TensorFlow, we have n times h times width times number of channels. So this is in PyTorch, and this right here is in TensorFlow. So what we'll do is we'll just permute the axis using a permute. So permute 0, 2, 3, 1. All right, so let me try to explain this. So we want the height right here, which is the second right in PyTorch. We want that to move to the first. We want the width to move to this the second dimension. Yeah, assuming this is the 0th dimension. And then we want the number of channels to be at the last one. All right, so then we'll do data tf convert to tensor of numpy array of that data. And then we'll do the same thing for the labels. So labels of NP array of labels. All right, so that's it for the train step. Now for the evaluation of the model, we'll send in a validation. So ds validation, I guess, and then model. And we'll have some accuracy metric to keep track of what the accuracy was across that the validation set, and that is Keras metrics sparse categorical accuracy. And then we'll do for index and then data comma labels in enumerate of that dataset validation. And we'll do the same thing as we did up here. So we'll just convert the data to have the correct dimensions, or the ordering of the dimensions rather. Then we'll do y prediction is model of data, and we'll set training equals false. And then we'll update the accuracy metric. We'll do that by doing accuracy metric dot update state of labels and then y prediction. Okay, so accuracy is then going to be accuracy metric dot result. And nothing really is too complicated here, I think. So that's why I'm going through it pretty quickly. And then we'll just print sort of the accuracy over that validation data. So accuracy over validation set was accuracy. All right, cool. So now we've done, let's see, we're now able to load the data, hopefully. We can get our model, we can do our train step, and we can evaluate our model. All right, so all that's left now, I guess, is just to set up the training. So we'll check if load model, then we'll print loading model, and then we'll do keras.models.load model of the model path. Right? If we want to continue training, if we've stopped the model and then rerunning it and so on. But otherwise, we'll just print building model, and we'll run that function that we just created, the get model, by doing model equals get model of that URL, and we'll specify the image size and then the number of classes. All right, so now we'll set up the optimizer. So that's going to be keras optimizers.atom. We'll just set a specific learning rate of 3e minus 4, and we're actually not going to be playing around too much. I'm just going to set it this way, but of course you could just babysit the model and lower the learning rate, or you could use a learning rate scheduler, and that would most likely improve the model. But I'm just going to do it this way. Then I want to create the loss function, which is going to be the losses sparse categorical cross entropy. And what's important here is that we specify that from largest is false. Otherwise, it won't train that well, I think. So then we'll create the accuracy metric. That's going to be keras metrics.sparse categorical accuracy. Yeah, so that's for the running accuracy. Okay, so the training loop, we'll just do for epoch in range of the num epochs that we set. In this case, I'm just going to be running for 3 epochs, so not that long. It's actually going to take less than 10 minutes to train on my GPU, which is a potato GPU. So you can probably run this on a larger model if you have a better GPU. All right, so then we'll do data and labels for enumerate of our training loader. Yeah. Okay, so then we'll just do the train step. So train step of data comma labels. We'll send in the accuracy metric as well. And then we need to send in the model, the loss function, and then the optimizer. Okay, so then what we'll check is if the index modulus 150 is 0 and the index is greater than 0, then we'll do training accuracy is accuracy metric dot result. So we'll just get the training accuracy, we'll print that, and remember this is a running training accuracy that sort of is the accuracy so far of the epoch. So we'll just do accuracy over epoch, and then maybe we can do so far or something. So to just be clear, and then we'll send in or print the training accuracy rather. Okay, then we'll evaluate as well. So we can do that once per epoch. Evaluate model on the dev loader and then the model. And then we can also save the model once per epoch to the model path. Actually, I saw this error right now. So what is the error? Okay, from dataset, define get loaders right there. All right, so now that doesn't officially count as an error. So, if I don't get an error this time, running it now, let's hope that it works and no errors. That would be amazing. So nice. God damn it. Okay. So what's the error? All right, so after some debugging, I found what the error was, and it's because we're wrapping this in a TF function, and then we're doing this permute and stuff, which is in PyTorch. So what we gotta do is just remove that from the train step, and just do it before we send it in to that function. And now it's going to work. So what I'm going to do is just run it for the 3 epochs, and then I'll see you when it's done. All right, so after just 3 epochs, we get an accuracy of over 63%, almost 64% on the validation data. That means that when we take a photo, it's top 1 accuracy, meaning the first prediction it makes or the highest prediction it makes is correct in 64% of cases. And if you think about it, that is actually pretty all right, because we have over 120 different dog breeds, and we haven't trained it first on a very large model, so you can definitely change that, and that would be very easy, right? You would just change this number right there to B3 or something, and then you would change the image size corresponding to that model. You can also lower the learning rate. We use the fixed 3 - 4, change that to something lower, use the learning rate scheduler. And then you can also expand the data set, and perhaps you can do this in a clever way such that you check which is the classes that the model actually has difficulty on, and then you'll scrape data for just those dog breeds. And there's also going to be a model available on the GitHub source code where I've trained a larger model on more data, which gets over 83% accuracy on the validation data set. So you can download that also. All right, so now we just gotta quickly convert this to a TF-Lite model. So we're just gonna check what is the directory that we saved it in, which is efficientnet b0. We'll create a converter, which is tf-lite.tf-lite converter from saved model, and then that saved model directory. We'll do the converter optimizations, and I mentioned this in the last zero-to deployment video as well, and I did this code. You can quantize the model as well, and you can read more about that. But for now, we're just gonna use float 16. So we'll do converter target spec supported types. We'll specify tf.float16. Then we'll do with open b0 tf_light. Then write as f. We'll do f.write tf_light model. Yeah, sorry. tf_light model is converter.convert. So that's the last step. Then tf_light.model. Okay, so let's run it. All right, so now that we have the B0 light model, which is about 10 megabytes in size, which is all right, we can now move on to creating the app. All right, so let's create a new Flutter project. And if you're completely new to Flutter, I would recommend you watch my first zero to deployment video, where I go into a little bit more explanation of Flutter and so on, and sort of introduce you to things in Flutter. But in this video, I'm going to assume that you've watched that one. So a little bit faster pace. And so what we'll do is just create DogNet, and we'll call it DogNet Mini because it's not going to be the full app. It's just going to be sort of a small version of it. And we'll do next, finish. Okay, so then we get sort of the default project. Again, I'm going to remove the test directory, and I'm also going to create the files that we're going to use. So this is going to be much simpler than the last one. We're just going to do a scratch file, which is going to be, we're going to do a Dart file, which is going to be a classifier, and then we'll have a main script, and that is it. Okay, so what we'll be doing is run app, and what we'll run is a material app. So we'll do run app, material app, and the home of this app is just going to be called home. So we'll create that class soon. And then we can specify a theme for this app. And so the theme data is going to be, we'll specify just some general things of how it's going to look like. So it's going to be brightness.light, primary color, colors light blue, 800, then accent color, colors cyan, 600. This is not really important, and I'm actually not sure. This is from the entire app, so I'm not sure if this is actually going to be needed that much for this smaller app. All right, so what's important here is actually creating this this home class. This is going to be a stateful widget, so we're going to do st_full. We'll call this home, and then for the home, we're going to return a scaffold. And what we'll do is we'll actually just run this and see that it works. And now we should have nothing for our app, but nevertheless, it should show something. All right, so as we can see, we have a white background. And so the app that we're going to create is going to, or the screen that we're going to create is going to look something like this. Although the thing that I was thinking about is having this take photo and this gallery sort of at the bottom in a row rather than a column like this. And then we'll have just some text showing here prediction, and then we'll show the prediction with the probability score and also what the breed name is. So that is just going to be a simplified, so we're not going to have this bottom navigation bar and so on, just to making this video a little bit shorter. So actually one thing that is pretty tricky is that we're going to be doing this, and we're going to be rounding the corners like this, which is a pretty silly thing to do, but it looks a little bit better. And for that, we got to do it a little bit more complicated. And what we'll do is, first of all, we specify the background color to be white. Then the body of this is going to be a stack, and it has to be a stack because we're going to put those two on top of each other, right? That's the way that if they're not, so the reason why they need to be on top of each other and need to be a stack is because, as you can see, this is just rounded edges, but that background image is still below this container right here, the white container. So we'll do body stack, and then we'll specify some children to that. And we'll use a positioned, so we'll specify where it will be positioned. So we'll use a positioned widget, and how we can specify the height and the width of that positioned widget is we can check what the size is of the screen that the user is that has the app on. So we can do size is media query dot, let's see, dot of, and then context dot size. And sorry, this should be inside the build method right there. So now we have the context and we have the size. So what we'll do for the positioned is, let's say we'll have a height of size.height times 0.4. So it'll cover 40% from the top of the screen. And the width will just be the entire width. And then let's just do a child of this is going to be a container. And then let's do the color of that is going to be red. But then later on we'll add the sort of the background image. But for now, let's just do a color. So as you can see, it will cover about 40%. And what we can do now is, let's see, so we'll do another positioned widget. So then other positioned widget is going to start from the top. And so it needs to, have some distance from the top. We'll specify that distance to be size.height times 0.35. And the reason why we do it 0.35 is because we want it to be some overlap. And then the height of that container is going to be size.height times 0.65. And in this way, they add up to 1, so they'll cover the entire screen. The width is just going to be size.width. Yeah, and then the child is just going to be a container where the color is just going to be colors white. It already is, but let's specify that color. And then what we'll do is we'll do a decoration to that container, specifying sort of how we can round those edges at the top left and top right. So we'll do that by using a box decoration widget. And then we need to specify the color inside of that box decoration. And then we'll do a border radius. And we'll do border radius dot only the top left. And we'll do radius dot circular, and then we'll do a radius of 36. Similarly for the top right, we'll just do radius dot circular of 36, and that should be it. So now we can see that it is actually rounded at the top right there, which looks pretty nice. All right, so after that, we want to have the buttons, right? So we want to have those buttons. And what I was thinking is that we have those buttons at the bottom, something like this. And then we have a text right here and another text right there. So let's do that. So in this positioned thing right there, inside of that container, we want to have a child of that container. And the child of that is going to be a column. So the column is going to have some children. And we'll specify first just some text. We'll do prediction. And then we'll do text. Let's just write golden retriever. And let's see what it looks like. So first of all, I want it to be down a little bit from the top. So we'll just use a size box of height of 80 to push it down a little bit. And then we'll also specify some styling to that text. And the text style is just going to have some font size to 40, and then font weight to font weight dot bold. So nothing difficult here, I guess. We're just making that bold and then a little bit larger, and then we'll just do Control-Alt-L to auto format the code. All right, and we'll do the same thing for the style of the golden retriever one. Except we'll just use a font size of 20 for that. And then let's do a color to be colors.green, and then also font weight dot bold. Like that. And then we'll see it shown like that. One thing I also want to show here is the sort of the percent of the prediction. So something like that. And then I would also want to have just a size box of a height of, let's say 10. So just some more space between them. And that looks pretty all right. So now we're gonna do a little bit more of the difficult part, which is that we're gonna create the button. The button is gonna be a row. So we're gonna do a row right there, and that row is gonna have some children. And what we're going to do is we're going to use a outline button. So there are different buttons you can use, but outline button is one of those ones you can use. So that's what it's going to look like at first. And then we can specify, we can do another one actually, because we're going to have two buttons. So those are right there. Then we can do main axis alignment for the row, and we can specify it to be at the center of the screen. So let's see, dot center like that. And what that will do is just put that centered. Now I want those to be a little bit further below. So we'll just do a size, so in between those, we'll do a sized box, and we'll just do, I don't know, a height of 80 maybe. So maybe a little bit more, let's say 90. Yeah, something like that. So we'll have some space between those, and then we'll also specify some space between the buttons themselves. So we got to specify some width, maybe 40, maybe even more than that, not sure, 60. All right, so now for the customization of those buttons. So for this customization of that particular button, we're going to change a couple of things. First of all, we're going to change the highlighted border color, change that to orange. I'll just move the screen for now. So we'll do highlighted border color to be orange, and then we'll do the highlight elevation to be 10. You can play around with these values depending on what you like. And then we'll do colors white on that. We'll do text colors white, and then we'll specify a shape of it. So we'll do circle border as shape, and let's just let's just see what it looks like right now. So now we have changed the button to be circular, and when we press it, we can see that it becomes orange, and also that it has some elevation when you press it. So that looks pretty nice. Want to make it a little bit bigger though, so I'll specify a padding of it, and we'll do edge insets dot all. So we'll just make it all around just larger. At least I thought that was going to happen. All right, it doesn't seem to make a difference. Yeah, all right, sorry. So for the padding here, that's going to be used later on. It's just to, we're going to display some text below it. But how we change the shape of it is that we can specify an icon. So we can do, I guess, child, and we can specify icon, and then the icon we can use is icons camera, for example, camera alt, and we will do a size of that one, and then that button will increase depending on the size of the icon, and then we'll do colors.orange for that one. So that's how it's going to look like, and when we press it, you can see that there's a nice outline right there. All right, so now that we want to have a text below this, we're actually going to have to make this into a column. So what we do is that we'll take this outline button, we'll just extract it, and we'll do a column right here. All right, so inside that column, we're going to specify some children, and what we'll do is we'll just send in that outline button, and then we'll do a padding widget, or rather we'll just do a text widget, take photo, and then we'll specify some style to that text. So we'll do text style, and we'll specify some font weight. Font weight is just going to be font weight.bold, and then we'll also specify some font size. 18 is what I found to look pretty good. We'll auto format that, and then this is what it looks like. Now, one thing is that I want to have some space between that. So what I'll do is I'll just wrap this widget with some padding, and then I'll do the animated padding. Okay, padding. So then I'll do padding is move that around, and for the padding I'll just do edge insets dot only, and then top only. So if we now bring that back, this is what it's going to look like. All right, pretty good. So what we'll do now is we'll just actually copy that entire column, and we'll replace this outline button with that column, and we'll just modify inside here. So what we'll do is we'll change this to be, let's see what icon I used. All right, so the icon we're going to use here is just going to be a photo, and then we'll change this to blue, and I think I chose a weight of 800. So that's what it's going to look like. And when we press it, there's still an orange outline, so we'll want to change that, this highlighted border color, to blue and 800 as well. Let's see, yeah, so that looks pretty good. Now what we want to do is change the background image, but before we do that, let's create our assets folder. So we'll create assets. Then inside that assets folder, I'm just going to drag over a background image. This is how it looks like. It'll be on GitHub if you also want to download it and use the same. Then we'll also take the model TF Lite. So I'll just drag that over to assets. All right, so now that we have all of those in our assets, let's close that. So now that we have those, we can go back to, let's see, where we have our red container right there. And we'll want to change that so that we have the background image instead. Now, how we do that is we specify a decoration to that container, which is going to be a box decoration. And we'll specify the image to be a decoration image. The image is then going to be asset image from assets, and then background.jpg. And then we'll do fit is box fit.cover. Okay. All right, and I think we also need to change the pubspec.yaml file so that in our assets, we'll also specify that we have a assets folder. And I think now is probably a good time to restart the entire app because we've made so many changes. All right, so the app looks pretty all right. I just want to also make it so that we have some functionality, right? So when we press this, we want to actually be able to take a photo. And let's see, so we'll go down to that button, and this on pressed is where we'll specify what we do when we press that button. So what we're going to do is I'm actually going to copy paste the code for that, and I'll explain what it does. It's pretty similar to what we did in the last video, but let me just also specify all of the variables that we're going to be using. So here we're going to be using a final classifier. We'll call it classifier, and we'll initialize that from classifier. Now we haven't done that one, so I'll comment that. But this is when we're running the TF Lite model. What we can, however, do is final picker is image picker. We're also going to have a string dog breed. And we're also going to have a string dog probability. And then we'll also have a variable image. So those are the things that we're going to use. And I notice now that we don't have the image picker package. So we'll do that, but let me just first explain some of the code. So this is what we saw previously. We're just doing a wait for the picker to get the image. So that might take some time, and that's why we're using this asynchronous function with await. And that's going to be from the camera. The height is going to be resized to be 300 by 300. And then the image quality is going to be 100. Then for the outputs, we're going to call our classifier and then in a function classify image of the image picked by the user. And then we'll do set state the dog breed to be outputs 0 and dog probability is outputs 1. But we'll see what that exactly is when we implement the classifier file. But all right, so let's do all of our imports that we're going to be using as well. All right, so we'll go to dependencies in the pubspec YAML folder. We'll go and I'll just copy paste the ones that we're going to be needing. So we're going to be using image picker. I'm not sure if we're going to be using this, but let's import it just in case. Image, and then we'll be using image compress, and then tf-lite flutter, and then tf-lite flutter helper. So then all you press is pub get, and then in the main file we'll do get dependencies, and that should be mostly it. But also we need to do the bat file for the tf-lite. If you didn't follow my first video, then do check that one first. But so I'm gonna go to, let's see, DogNet mini, and I'm gonna copy paste the Windows bat file, and I'll just run that, and that'll install the what we need for tf-lite. And so you can download that from the tf-lite Flutter package, and I'll make a link below so you can download it if you didn't watch the first video. All right, so what we can do then is we can actually import those packages. So we can do import package, DogNet, DogNet classifier.dart. So we gotta create that one as well. And then we'll do import dart.io, and then we'll also do image picker. All right, so we haven't done that one. I guess we can comment that for now. And so if we scroll down now, hopefully we can just comment this part, but hopefully the image picker should work. So if we just restart it and then press this one. All right, yeah, so I figured out what's wrong. This is actually for the take photo. So I'll just I'll just copy this and then move up to the first column, and then inside this outline button is where we want to get from the camera. So let's try if that works. Yeah, so this is what the camera looks like. You can just take a photo and that should work. So what we want to do for the other button is that we want to do image source is from the gallery instead. So if we press that one, we go to the gallery. All right, so now we have pretty much all of the functionality for this screen, but we need to, create so that we can actually run our model. And so we need to, create this classifier file. And let's start with the import. So we're going to do dart.io. We're going to be using tf-lite flutter, and we're also going to be using the tf-lite helper, tf-lite helper. So to start with, let's create the class classifier, and all we'll do is first create an empty, initialize it with no input, and then we'll do classify image of some variable image, and this is going to be an asynchronous function because it might take some time for the model to run and so on. And we'll create the input image first. So the input image is going to be file of image.path. Then we'll create an image processor, and that image processor is just going to be an image processor builder. And then what we can do to that is we can do .add, and we can add a resize operation in case it wasn't already resized. So resize operation is going to be 300, 300. And the reason here why I'm resizing, by the way, to 300 rather than 224, which is what we trained the model on, is because the tf-lite model I'm using is the one with that I trained that got 83% accuracy, which was trained using EfficientNet B3. And so that one has an input size of 300 by 300. All right, so we'll specify here the resize method. So resize method dot bilinear, and then we'll do dot add and then normalize operation. And so the mean is 0, and then the standard deviation is 255. And we'll do .build at the end. All right, so that's it for the image processor. Then we'll create a tensor image, and we'll just call that tensor image. We'll do tensor image from file, so from that input image that we send in. And then we'll just process that tensor image, which we'll do using that image processor that we just built. And how we do that is by doing image processor.process and then the specific image that we're sending in, so tensor image. All right, so then we'll create the tensor buffer, and the tensor buffer is going to be for the probabilities that we get as output. So we'll just call this probability buffer, and we do tensor buffer dot create fixed size, and it's going to be of integer, and it's going to be a size 1 and 127 because we have 127 different dog breeds. Then for the data type, we'll specify it to be tflight dot float32. So I guess dot float32. Okay. And then we'll do a try block. So try except in Python. And what we'll do here is we'll try to create our interpreter. So interpreter, and we'll just call it interpreter. And that's going to be await interpreter from asset, and then we'll specify the name, which is just model.tflight. Now that we've created the interpreter, all we got to do is just run it. So we'll do interpreter.run, and we'll send in tensor image.buffer and then probability buffer.buffer. And then we'll complete the try except block, or the try catch block, and we'll do catch, and we'll just do print error loading or running model. And that's it for the try except block. And now what we can do is I'm going to copy in this last code because I think the video is running really long. So I'm just going to copy in the last code, but I'll just go through it, but it'll be a little bit faster. So what we're doing here is that we're loading a labels text, and we actually got to create that as well, I notice now. All right, so I'll drag that over to assets as well. And this is just the names of the dog breeds in a text file. And so that's all it is. But what we'll do here is that we'll load that labels as a list of strings. We have another probability processor, which is a tensor processor. And then we'll do tensor processor builder.build. And we'll get the tensor label by doing tensor label.fromList. And then we'll send in the labels, and then we'll also do probability processor of the probability buffer, which is sort of the output values, right? The probabilities that we get from running our model. And then we'll get a map instead. So we'll do tensor label.getMap with float value. So this will be a dictionary in Python or a map in Dart. And then this last code right here is just that we're checking what is the highest probability and what is the dog, not dog name, dog breed is a better name, dog breed. So what we'll do is that we'll go through each key and value in that map, and we'll multiply the probability by 100, and we'll check if that is greater than the highest probability, which is initially set as 0. Then we'll set that highest probability to probability times 100, and that dog breed is equal to, let's see, yeah, so let's just call this breed, but we'll set the dog breed equal that breed. And then we'll change this highest probability and just round that to having a single decimal. And then we'll return the dog breed and the output probability in a list. So that's it for the classifier and how we run the classifier using TF like Flutter. And now hopefully we can remove this thing right here, and we can, run the classify image, and then we can also initialize our classifier, and we also then need to import it. So now let's see if that works. All right, so to import it, we just got to do classifier, and then we'll do classifier.dart. And that should be it. So now we can initialize that classifier, and hopefully we can also run it, let's see, later on over here. And what we're doing is that we're running it and we're getting some outputs, that list of the dog breed and the dog probability. And then we're just setting the state of the dog breed and the dog probability. And we're doing that because we're going to update the text depending on those values. And then we got to do the same for the other button. So yeah, we've already done that. Yeah. So then all we need to do now is just change the text right here to be displayed dependent on what we run. All right, so how we'll do that is we'll use a ternary operator similar to last video, and we'll check is dog breed empty, meaning it has not run any prediction. So if it is that, then we'll just show no prediction, but otherwise we'll show the dog probability, and then we'll do %, and then we'll also show the dog breed like that. And as you can see, it's null and null right now. But if we rerun the entire app, and we can see that something is not working. So what we can do, I guess, is specify this to be an empty string in the beginning. And that should certainly work, I think. So now it's just showing nothing. But if we go to this right there, and I just noticed that it should not say take a photo right there. It should say something like from gallery. So from gallery, like that. When we press that, we'll get to the images. We can press an image, and then it should show the prediction. In this case, it's very unsure because it's not a dog. So it's a 1% Mexican hairless, and then that should be dependent on what you send in. All right, so one thing that could also be cool to do is in this first position widget where we're showing the asset image, would also be cool to show the uploaded prediction. And how we can do that is pretty simple, in similar to how we did the text thing. So we're gonna check using a ternary operator, check if this is empty, meaning there hasn't been no prediction so far. And if it hasn't, then we'll do file of image.path, and then we'll do fit. Yeah, sorry, we've already done that. Yeah. So then that should hopefully work. And now we can see that in the background right there. I should probably just upload a couple of images of some dogs, but anyways, I'm quite confident that this is working. You can try it out with some images of dogs and see if it works and if it works well. All right, so let's just check if it works. I'm just taking an image of Affenpinscher. So let's go to downloads. Oh, we have those images there. Okay, so let's pick that anyways. And then it shows 99.1% Affenpinscher, which is correct. And this is from the dev set, so it hasn't seen those examples. All right, that is it for another 0-2 deployment video. We created another app completely from scratch. Pretty cool. And check it out on the Play Store. It's called DogNet. And I just want to say thank you guys so much for watching the video. I really appreciate all the support, and see you in the next video.